Welcome back. Today we'll look at paper 22, also of the October-November 2023 series. And of course, since this is an old paper, then the mark scheme is available online. Right, therefore, as well as watching this video, I will also recommend, make sure to check the mark scheme as well. And of course, if the video is too slow, then you can watch at 1.25 or 1.5 times the speed. Right, it says we should refer to the insert for the list of pseudocode functions and operators. So of course, if you don't have this, just go online, type in like 9618 pseudocode insert, and yeah, you should be able to find this on any of the past paper websites. Right, question 1. A shop sells car accessories. A custom order is created if an item cannot be supplied from current stock. A program is being developed to create and manage the customer orders. Okay, the following identifier table shows some of the data that will be stored for each order. Right, complete the identifier table by adding meaningful variable names and appropriate data types. Alright, so if we see the first one then, of course here we see double quotes, right, therefore we know that's going to be a string. Hang on. Okay, yeah, so let's just write string here. Now, as for the variable name, of course we could just say name, but there might also be, probably not a car name, but there could be something like part name. Or yeah, there could be, maybe the kind of staff name. So I think, we don't really just want to say name, right? Let's be a bit more specific. And yeah, let's say customer name. Right, and then I guess for the next one, right, 3, the number of items in the order. So let's, maybe just like num items. And of course, since that's just the number of items, right, that can only be an integer. Obviously we can't have like 3.5 items. Right, then true to indicate whether this is a new customer. Now, for me, let's just say Boolean. But for me, with Booleans, rather than just saying, for example, new customer, because if we say new customer, that could be a record, maybe that could be their name. I actually like to start Booleans with is. So yeah, if we say is new customer, then of course, because we're using is, right, that should make it fairly obvious that this is going to be a Boolean value. Right, then 15.75, of course that's going to be a real. And the deposit, so I guess here we can just go deposit, or yeah, maybe deposit amount. Right, other variables in the program have example values as shown, right, total 124, that's a real number, right, deposit rate, okay, 2, and yeah, some description. Right, complete the table by evaluating each expression using the example values. Right, so of course, obviously, yeah, just going left to right. Right, total multiplied by deposit rate, so that's going to be 248. Then 248 plus 1.5, so that should be 249.5. Right, then we do right, description, and 7. Yeah, okay, let's just say, right, if you don't know this, then of course, you can refer to the pseudocode insert as it tells you. But what we say then is, right, that's just going to get these 7 these 7 rightmost characters in this case. So if we think here, let's count, right, so 1, 2, 3, 4, 5, 6, all right, 7. So yeah, and here, right, since this is a string, let's make sure to actually use the double quotes. Okay, and then you have the closing bracket on that small. Right, then length description minus 8 is greater than 16. So of course length, that's going to count how many characters. Now, this one's going to be quite long, so let's just count them. Yeah, so 1, 2, 3, 4. Right, I'm going to count in my head. Okay, so I think, yeah, I just did that, right, I think it's going to be 30. So if we go, 30 minus 8 greater than 16, of course, right, that's going to be 24. So yeah, this should therefore be true. Right, then we have, so we do deposit rate times 10, which is going to be 20. Right, then we, then we just use int. So int means, let's say we have something like, 20.999. Int just means round down, or effectively, just remove the decimal part. Yeah, so only keep the integer part effectively. Yeah, of course, in this case, it's going to be the same because, we've just got 20. Right, then num to string, so of course that's going to become the string 20. Right, then we're going to concatenate, so join the strings, and we're just joining it with this percentage character. So again, right, let's make sure to put this inside a string or inside quotes, and yeah, that should just be 20%. Okay, the data that needs to be stored for each customer order in part A is not all of the same type. Describe an effective way of storing this data for many customer orders, right, while the program is running. So if, for example, we have, let's say like an object, so in this case, well, the object is going to be customer, and we say that, well, each instance, okay, okay, so let's say, that object is going to have different attributes. Of course, well, in this case, we saw the name, like is new customer, right, etc. Now, of course, if it's the same type, well, then we can just use, a 2D array. So I guess we're a 2D array with obviously like, 2 columns if we want 2 fields. 3 if we want 3 fields. But of course, an array, they all have to be the same data type. Now, if we want different data types, then we can use a record. But in this case, well, of course, a record is only going to store one customer, right? Therefore, we're going to need an array of records. Let's just say that. Maybe create an array of customer records. Let's say what, to store each individual customer, or to store each customer. Let's say, well, to store each customer's details. Let's say, right, the record, and here we'll mention the fields for all the attributes it will have. Let's say what the record will have, what the following fields. And I don't know, like probably here we don't really have to say them again, but of course, well, just the name, the number of items, right, is new customer deposit. Let's say, the record will have the fields. Let's say, right, the fields stated above. And let's just give an example, right, e.g. customer name. And then because, well, since it talks, right, while the program is running, possibly they're asking like how we can actually access this, or how we can actually use it. So of course the way we can do that is what we have something like customer. Right, then we can have, well, the array index. Let's say, for example, 5. And then, for example, we can of course go dots. Right, and then let's say customer name. And then I know here we can assign it a new value, for example. Like we can, possibly we might get a mark for mentioning this. So let's say what we can, we can use, maybe let's say we can use an index to access a specific customer. Let's see specific customer at runtime. Since again, here they mention runtime in the question. And let's say what then, and I guess we can say what the dot notation. The dot, right, the period. Let's say, right, then the dot notation to access specific fields or specific attributes. So is that enough? Right, create an array of customer records. Hopefully that'll be 2, right? 1 for saying array, 1 for saying records. Right, to store each customer's details, the record will have the following fields, stated. Right, that we can then use, index number and I guess dot notation. Right, so hopefully this will be enough for 3. I think for this one, right, I would also check the mark scheme, just see what they say. Okay, then 2, an algorithm will input a sequence of integer values one at a time. It will ignore all values until the value 27 is input, then sum the remaining values in the sequence, and it will then stop summing values when the input value is 0, and then output the sum of the values. So what this is saying, well, let's say we have the inputs, I don't know, maybe 5, 2, let's say 27, right, 4, 6, right, 3, and let's say 0. Well, of course, it's saying, well, these ones before 27 are just going to be ignored. And what is it saying? Right, ignore all values until the value 27 is input. Right here, then sum the remaining values. Right, so 27 is also ignored. So of course, in this case, we're just going to be summing these 3. And then 0, right, that's the stopping condition. So I guess what this will say, 13 will be output. Right, so I guess first then, well, let's just declare some variables. So probably, I think here we're only going to need 1, right? We're only going to need the sum. So let's just go set. right? Yeah, set sum, right, to 0. Right, and I think here then, after we've done this, well, then we can just have a loop. And of course, in this loop, well, we're just going to have them input a number, yeah, until it's 27. So, right, I mean, let's just sort of draw this. And, I mean, well, for input, then that's going to be the parallelogram. And actually, we should... Yeah, okay, hang on. I'm just going to extend this a bit. Because, I mean, of course, well, we will need somewhere to actually... yeah, although, like, maybe we don't really have to declare this. You know, I guess, well, we will need somewhere to actually store the num that we're inputting. So let's go, right, set num. Let's go, yeah, set num to 0. Okay, right, then we just want to input into num. Right, and then so here, well, here's where we can have the is, right, the if condition. And right, that's going to be a diamond. So, well, let's say is, and we're going to check, right, is num, and that's going to be what, equal to 27. And yeah, I think here they usually have the question mark. Right, so well, if it's not, then we're just going to go back. So yeah, let's write no. But if it is, so yeah, let's write yes. Right, well, then what do we want to do? We just want another loop, and we just want to sum them. Right, so again, let's just go input. So again, right, yeah, just input num. And I suppose, I mean, like, actually, in this case, we actually don't have to check if it's 0 first, because, of course, what if we just add 0? I mean, adding 0 is, of course, just having no effect. So, yeah, I mean, let's just add this. And if we're doing add, well, that's just going to be the rectangle like this. So, right, let's go set, and this will be, what do we say, sum? Yeah, so set sum, right, 2, and that's going to be what, sum, and then plus num. And of course, yeah, we can just expand that out. Right, then we're going to want the another, yeah, I guess the other condition, or yeah, another condition. So let's go is, and let's say, right, is num equal to 0. Right, well, if it's not, then we're just going to go back again, have another loop, and again, make sure to write no. If it is what we just want to output, yeah, then we just want to output. I think I've just about got space here. So let's just go output. And actually, sometimes for this, you know, they do actually like you to give a message. So let's just say sum. And let's have, for example, the colon. All right, and then here, let's just go sum like this. And of course, yeah, in the exam room, make sure to give yourself enough space. Right, and then, yeah, we'll just have it connected to the end. Right, the solution to the algorithm includes iteration, give the name of a suitable loop structure that could be used, and justify your answer. Well, I mean, when it says suitable loop structure, I mean, I suppose, yeah, when they're saying, you know, loop structure or maybe sort of like control structure, like they're not really looking for, let's say, just the sort of simple name, like, you know, if statement or, yeah, for loop. They're looking for the more kind of generalized name. So if we think, well, for loops, that's going to be called count controlled. Right, there's also then going to be what, a pre-conditional and post-conditional. So I think here, I mean, let's just write pre-conditional. Yeah, I mean, yeah, so I guess or we could do post-conditional, you know, they would both be okay. But let's just go pre-conditional here. And, well, when we say pre-conditional, what this means is that, well, I mean, you're going to check the condition, right? Then you're going to sort of execute the code. So effectively, well, this is just going to be a while statement, or yeah, a while loop. Because of course, well, here, you know, we have while, right? Then we have the condition. And what if this condition is true? You know, of course, right then we execute the code. In contrast, if we look at a post-conditional loop, well, a post-conditional loop, that's going to be repeat until. And well, yeah, let's just go until. And again, we're going to have the condition here. So of course, in this case, well, I mean, first we're going to run the code, right? Then once we've run the code one time, right, then we're going to check the condition. So of course, well, the difference is that let's say a preconditional loop might never execute the code, because, you know, if this if this while condition is false, right, then of course, yeah, it's just never going to execute the code inside the loop. Whereas the repeat until, right, that's always going to execute the code inside the loop at least one time. So I'm just going to say preconditional, and then in brackets I'm also just going to say while loop. Right, justification, and I suppose here, well, the reason is we don't know how many times they're going to enter like invalid, or yeah, okay, I guess we don't know how many times they're going to enter numbers, like until it's 27, and yeah, of course, until it's 0. So let's try and say that, I guess, yeah, we don't know, yeah, how many numbers, right, the user will enter until 27 or 0. Yeah, whereas of course, something like a count controlled loop, well, a count controlled loop we can only know if we know how many times to loop in advance. And I mean, like this, this doesn't have to be like an actual hard coded value like 10. Of course, we can also loop up until a variable, but as long as we have some way of knowing, right, either it can be in a variable, right, or it can be hard coded. Yeah, then we can use count controlled, right? Otherwise, we have to use preconditional or post-conditional. Number 3 says the diagram represents a linked list abstract data type, or ADT. Right, pointer 1 is the start pointer, pointer 2 is the free list pointer. Labels D40, right, 32, 11, and 100 represent the data items of nodes in the list. And right, labels F, right, 1, 2, 3, 4 represent the data items of nodes in the free list. And right, this kind of O symbol represents a null pointer. Okay, the linked list is implemented using 2 variables and 2 1D arrays as shown. The pointer variables and the elements of the pointer array store the indices, right, index numbers, of elements in the data array. Right, complete the diagram to show how the linked list, as shown above, may be represented using the variables and arrays. Okay, so yeah, let's just zoom out so we can sort of see everything. Right, so let's look here then at pointer 1. We see that's pointing to D40. Now, if we look, D40 is here. So, right, for the start pointer, we're just going to write 4. Since, of course, it's pointing to this. Right, then if we look at D40, D40 is pointing to, this D32 value. So we see D32, right, that's in index 1. So, yeah, we say that, this first element is therefore pointing to index 1. Right, then if we go to D32, right, that's pointing to, 2. And then we see, this has D11 as the value. Right, then 3. That's pointing to D100. So in 3, let's just write D100. And then we say, this is then pointing to the null pointer. So I suppose, let's just write the null pointer here like that. Right, then if we look at the free list pointer, so here it's telling us it's 5. Okay, alright, so, I guess here we see 5 is empty, right, therefore we need to write F1 in this position. Right, F1 then points to F2, as we can see here, and we see F2 is going to be index 6, so let's write index 6. Right, then if we go, so it says here that, right, this points to 7, and we see, 7 is therefore going to contain S3, F3. Right, and then, that's going to point to F4, so let's just write F4 here. Let's write 8 here, and yeah, this is going to be another null pointer. And I suppose, these, of course, you can quite easily check this just by, traversing through the list and making sure your table is correct. Right, the original linked list is to be modified. A new node D6 is inserted between nodes D32 and D11. Right, the algorithm required is expressed in 4 steps as shown. Right, complete the steps. Right, so let's think then between D32 and D11. So what we're going to say, if we have this, what's going to happen? This pointer is therefore going to point to this one. We're then going to have, this one is, then going to point to D11. And of course, what we're going to call this D6, D6 will be, let's say, the value, right, the data, stored at this index in the array. Right, so, let's try and go through that. We want to assign the data item to something. So I think, let's say assign data item D6, and I think, what we want to say then, this is going to be F1. And if we see here, right, so F1 is index 5. So I think I'm going to say, I don't know, I'm just going to say index 5. And I think in brackets, you can probably put F1. Right, then set the something of this node to point to something. So I guess if you're setting, it's going to be the pointer. Right, so set the pointer of this node. Well, we said here this will point to D11. Yeah, okay, D11. Right, then set pointer to. So right, pointer to, this is the free list pointer. Right, therefore, of course, that's going to point here to F2. Yeah, and so hang on, wait, what is F2? F2 is index 6. So yeah, maybe let's put in brackets here. Right, then set pointer of something to point to something. So I guess what that's going to be this one. So let's say what, D32. Right, that's going to point to D6. And we said what, D6 is going to be index 5. Yeah, because we said, hang on, right, so D6 is index 5, right, according to this. So right, let's go index 5. And right, D32. Right, okay, that was index 1. Okay, right, the next one, a procedure count will input a value, right, all values will be positive integers. Then it will count the number of odd values and count the number of even values. It will repeat from step 1 until the value input is 99, and it will output the 2 count values with a suitable message. Right, the value 99 must not be counted, and write pseudocode for the procedure count. Right, I've just loaded this in the site and we'll have a go. So this is going to be a procedure, right, it's going to be called count. And I think here we have no parameters, and yeah, I'm just going to get end procedure. Right, then what we want to do, so well, let's just declare the local variables we need. I suppose, well, one is just going to be this value. Right, we're also going to need what, an odd count. Yeah, we're also going to need an even count, and then I think, yeah, that should probably be all we need. Right, then let's, well, yeah, let's just initialize. So let's go odd count, and that's going to be initialized to 0. Likewise, even count, that's going to be initialized to 0. And I mean, for this, well, either you can use a while loop, right, or you can use repeat until. I think for me, I'm just going to use repeat until for this one. Right, so let's go output, and yeah, let's go enter a number. Although to be honest, in this case, you can use while, right? I mean, that's just as good. Right, let's go input then, and we want to input this into value, and I'm just going to say if. So let's say if the value is what, not equal to 99. Well, yeah, then what we want to do, and I suppose here then we want to check what if it's odd or even, and the way we can check if it's odd or even is, well, we just do the value mod 2. Right, let's go, yeah, value mod 2, and if that's equal to 0, right, well, that, yeah, right, then it's going to be even. So let's go even count, right, even count, and we'll just increment that. Right, let's go else, and we'll go end if, and then of course in the else, well, here it's therefore going to be odd. So yeah, we'll then just increment the odd count like this. Yeah, and then that should be okay. And then what do we want to do? We just want to output at the end. Yeah, okay. Right, and then, well, let's go until. So what this will be, until value is equal to 99. And then at the end, well, let's say, I don't know, maybe what, even count, or yeah, number of evens. And that's going to be what, the even count. Yeah, I'm maybe a bit lazy, let's just copy it. Right, and then let's go odd count, and let's go odd count. Right, and then, well, of course, in the exam, you don't have to test it, but I mean, let's just test it to actually see if it's working. Right, enter a number, let's try 5, let's try 6, right, maybe 2, let's try 4, and let's try 9. Right, then let's just go 19, oh, okay, hang on, yeah, 99, right, not 999. So yeah, here it's saying even, which is 3. Yeah, because I guess I didn't really mean to do this 999. But yeah, I guess, I mean, this seems correct now. Alright, and then if we look at the next one, the procedure count is to be tested, and I'm just going to zoom in a bit. Right, typical test data would consist of odd and even values. Right, for example, this. The purpose of this test would be to test a typical mix of even and odd values and check the totals. Right, give 3 test data sequences that may be used to test different aspects of the procedure. Right, do not include invalid test data. Okay, so maybe we can have something like, I suppose, well, I mean, let's have one where we have more evens. Yeah, we could have another one where we have more odds, or yeah, maybe an equal number. And then I suppose maybe another test, we can have it where if they enter, 99 first, because, well, of course, if they enter 99 first, right, then it should just say 0. So yeah, like maybe we can do this one first. Let's say what, to ensure both counts are 0. Right, let's have another test data. Maybe we can go, I don't know, let's say 4. Yeah, let's try 8. All right, 7. And right then, let's go 99. Well, let's say, I don't know, yeah, to ensure that, the even count is bigger than the odd count. Well, let's say, yeah, to ensure the even numbers are counted correctly. And I think what I'll do, right, I'm just going to expand this answer. So let's say what more than odd count, because of course, well, there should be 2 evens, right, and 1 odd. Okay, and then I mean test 3. Well, I mean let's have more odds. So I mean let's go what 9. Let's go I don't know, maybe 9 9. Let's say 7, right, 2, and then 99. Well, yeah, to ensure odds are counted correctly. Yeah, right, odds are counted correctly. And what? So I guess what there should be more than evens. Yeah, I mean to be honest, this question seems a bit strange because like 2 and 3. I mean, I don't know. It seems like you could do this just in one test. Because obviously, well, here, you can check what the even count should be 2, the odd count should be 1. So I feel like, this test is kind of redundant. It's not really needed. Right, but anyway, the next one. So a global 1D array of integers contains 4 elements which are assigned values as shown. Right, so what 1, 3, 4, 2. Right, a procedure process manipulates the values in the array. Right, it's written in pseudocode. So right, we're going to declare some variables. Right, I guess it's going to take this start as an input. Well, start as a an argument, right, parameter. Right, it's then going to assign start to index. It's going to set the count to 1, and it's going to repeat. So it's going to take the current element in mix, and it's going to assign this to value. Right, then it's going to decrement the current. Well, it's going to decrement the current index. Right, then it's going to update the index to be the new value. Right, then it's just going to increment this count variable, and it's going to do this 5 times. And right, finally, then it's going to do count multiplied by the index and store this in position 4 or at index 4. So it seems, yeah, this is kind of like the result. Yeah, I guess the sort of result index basically. Right, then complete the trace table on the opposite page by dry running the procedure when it is called as follows. Right, so calling with let's say an argument of 3. Right, I've gone ahead and split screen them just so we can see this. So right, I think first then, if we look here, this mix, of course this mix array, we've not actually put these values in the trace table, or yeah, I guess they've not pre-populated them. So let's just go ahead and do this. Right, then if we look at the algorithm, so here then, we're using 3 as the argument. So we're saying, start is assigned to index, and if we actually look, of course, none of these are starts, so yeah, we don't actually have to write the start value. But okay, so we want to assign that to index. Now, I will be honest, I mean, I'm not really sure, should we start a new row here, should we not? Because honestly, it seems like each mark scheme is kind of different, when they actually start a new row. I think for me, I mean, let's just do it here. So right, okay, that's going to be 3. Right, then we're just going to initialize count to 0. Right, then we're going to repeat. So, I mean, of course, if we're looping, then we should start a new row. Right, let's go. Okay, so we get the mix index. Right, the index is 3. Right, therefore, 3 has this value 4, and we're just going to assign that to value. Right, then we're just going to decrement this, I guess this index, right, so this is going to go to 3, or, okay, let's say we're going to decrement the element, right, at that index. Right, then we're going to go, index and assign it value. Now, I do notice here, right, in the mark scheme, they do start a new row. Now, I've tried contacting Cambridge, asking on the forums, and it seems, I mean, no one can give me a good answer, when we should start a new row. Also, I tried asking, what happens, let's say, if a student gets the correct result, but, for example, let's say, they have their answer written here on this row, but, in the mark scheme here, it's written on this row, I mean, basically, would that be considered correct, right, by an examiner? And again, I mean, let's say no one could really give me a good answer. So, yeah, honestly, for this, right, I'm not really sure, probably I'll try asking again, right, if I get a good response, then, yeah, I'll probably just leave it in the comments. Like one thing I was told, well, I mean, this was on the AQA, right? So AQA, they actually have a document, and I mean, yeah, I think this is huge. It's like 30 pages just about trace tables. But what they say is, well, they say that trace tables should be read from left to right, and then, well, you know, top to bottom. So I guess similar to how obviously many languages read. Of course, well, some languages are, you know, sort of right to left. And yeah, I guess maybe even fewer are kind of what, like down, top to bottom, you know, then left to right. But yeah, I think generally probably most languages in the world, right, they're going to be left to right, then, you know, top to bottom. So like what they're saying is, well, because here, yeah, I guess for this one, well, we've assigned in this column, and of course, well, we're going left to right. Yeah, well, okay, that right, then we do this one. But now let's say the next one here, well, we want to update the index. So of course, well, here, this is going to be further left. So for that, we actually can't do it. Okay, we have to start a new row. So here then, well, this is why we write for. Oh, well, okay, yeah, I guess, well, this is not why we write for. This is possibly why we write for. But the problem is, right, other mark schemes, you know, they don't adhere to this same rule. So again, yeah, like, well, I mean, whether this is something Cambridge follows or whether it's not. I mean, when I asked them before, again, no one could give me an answer, yes or no. So yeah, I don't know, it just seems random every year how they actually, you know, make the mark schemes for these trace tables. But anyway, so well, let's go next, right? Count is then just getting an increment, so count is going to go to 1. Right, then we have another loop, so right, this time we get the index. Right, the index is 4, so right, that element is going to be 2. Let's just assign that to value. Right, then we're going to decrement this, so this is going to become 1. Right, then we copy this, and again, let's start a new row. Yeah, although, I mean, hopefully if you did do it on the same row, I mean, hopefully they would accept that, you know, the examiner. Right, then we just want to right, increment count again. Then the next row, so we see the index is 2. Right, therefore the value at 2 is going to be 3. Right, let's copy that. Right, we then decrement that, so yeah, this is going to become 2. Right, we copy the value into the index, and then we will increment the count, so that's going to be 3. Right, the next one, so the index is 3, right, therefore, okay, that's going to be, well, okay, so that's still going to be 3. Now, I guess technically if it's still 3, we actually probably wouldn't need to write this, although I think here I'm going to write it, you know, just in case. Right, then what do? We're going to decrement that, so yeah, this one is going to become 2. Right, we then copy this right into the index, and yeah, let's increment the count. And then right, I think the last one, so right, so the index is 3, right, and then that value is going to be 2. Okay, right, then we're going to decrement that, so that's going to become 1. We're going to copy the value into the index, and right, then we're just going to increment the count. And of course here, well, until count equals 5, so now this will be true. Right, then we're just going to do count multiplied by index, so what, 2 times 5, right, that's going to be 10. And I think here, since we're outside of the loop, well, let's just write this here, right on a new row. Number 6, a procedure to create files will take 2 parameters, a string representing a file name and an integer representing the number of files to be created. The procedure will create the number of text files specified, and each file is given a different name. Right, each file name is formed by concatenating the file name with a suffix based on the file number. Right, the suffix is always 3 characters. For example, the call create files test data 3 would result in the creation of the 3 files test data, right, 001, yeah, obviously 2 and 3. Each file will contain a single line, right? For example, test data 2 will contain the string this is file test data 2, and we have to write pseudocode for create files, and we can assume that both parameters are valid and that the integer value is between 1 and right 999 inclusive. Let's go ahead then and just create the procedure. Now, I think what I said, the first parameter, well, let's call it file name, right, that can be of type string. And then what the next parameter, let's say maybe amount, and yeah, that's going to be an integer. Right, then what we want to do, well, I mean, let's think of any local variables we might need. So I suppose one, I mean, well, of course we're going to need a for loop, so let's just create an index variable. I think we might also need, let's say like a new file name. where of course, yeah, this is going to have what the file name, right, concatenated with, okay, well, obviously the number. So yeah, I mean, let's just say that, right, let's say, yeah, new file name, and of course, right, that can also be a string. Now, I mean, hopefully that's enough, but I mean, yeah, I guess what I will leave myself space in case I need to go back, right, and yeah, add some more. So let's say, well, first then we just want to loop through, and this will be what index, let's go 1, and then we'll just go 2 amount. Right, then what we want to think is, well, how do we actually generate this file name? Or yeah, how do we kind of generate the number? Because let's say, for example, if we have, well, okay, let's say if we have 1, right, of course, well, we have to, well, prepend that with 2 zeros. And we can say, well, any number in the range 0 to 9, so if it's a single digit, right, then of course we're going to need sort of what, 2 zeros. If we have 2 digits, so of course what, 10 to 99, right, then of course we only need to prepend it with one zero, and of course, well, if it's 3 digits, right, we don't need any zeros. Now, to be honest, I mean, yeah, there is actually a better way to do this, and I think if we go here, right, on one of the challenges, I think one of them is called pad, and yeah, there you can see a sort of more generalized way of doing it. Like if you want to say, well, I don't know, maybe this time we want, 12 padding, say like 12 zeros padded. Yeah, maybe the next time we want, 5 zeros. But I think for this one it's sort of quite simple, okay, because there's only 3 different conditions. So let's go if, and well, the way we can check if it's a single digit, I mean, of course you could do it by, converting to a string, but I mean, what we can really do is, well, let's go index, and we check if this is less than 10. Right, then if it is, let's go what, new file name, and that's going to be the file name. Right, then let's go and we'll go the dot. Right, let's go 2 zeros, and then it's going to be, and I suppose, I mean, since this is a number, right, let's actually use num to string. Right, and then that's going to be, yeah, index. Yeah, okay. Right, yeah, so I'm here, let's just do else, and then we'll go, right, if again. And this will be what, if index is less than 100. Right, let's have the else, let's have the end if. And yeah, I'm just going to do the, okay, I'm going to do both of the end ifs first. Right, so I mean here, right, I'm just going to copy this because, I mean, basically it's the same. Right, but of course, well, here we only want 1 0. And then, right, else. Okay, and then, well, here, yeah, I guess, well, obviously here we just don't want any zeros. Now, I think, I mean, hopefully that should be working. But of course, well, now what we want to do, we actually want to, well, open this file, okay, create the file. So, right, let's go open file, and that's going to be the new file name. Right, then we want to say, right, for write. Right, then we just want to write the file. And again, well, let's say new file name, and then what we say the data. And I think the data, what this, yeah, maybe this is, yeah, okay, so we see, right, this is file, and then the file name. Yeah, and then right here, let's just go and like that. And well, this will be the new file name. And once we've done that, okay, let's remember, let's just close this. And right then, let's go next index. And yeah, let's check if that's everything. Yeah, I mean, I think that's everything. So I mean, let's just try like with what they, yeah, the example they give. So right, they call it test data, and let's just go 3. Yeah, and I think that seems to work, right? So this is right, test data 1, right, 2, and yeah, 3. Okay, then it says a module check files will count the number of files produced by create files in part A. Check files will take a string representing a file name and return the number of files found. Right, identify the type of module that should be used for check files. So of course, when it says type of module, well, functional procedure. And since here it's saying return, well, of course, right, that's going to be a function. Right, write the module header for check files. Okay, so let's just go function. Right, of course, well, then we have the name, right, the identifier, check files. Right, let's think about the parameters. It says it will take a string. So, I mean, well, let's call it, yeah, okay, that's the file name. And I suppose, well, this will be like the base file name. Yeah, so I think, I mean, this would just be what, like test data or test file. And then, of course, it's going to search what is their file, 001002. Right, it's just going to keep searching. Right, so of course, well, that's going to be that's going to be type string. And then we just go what returns, and it's going to return a number. So well, let's go integer. So yeah, let's go returns. Right, make sure you have the s, and yeah, that's going to be integer. Okay, right, state the file mode that should be used in check files. I mean, I suppose, well, read. Yeah, I mean, okay, well, let's just go read. Although, like, the thing is, pseudocode doesn't actually have a way to check if a file exists or not. So, yeah, I mean, this question is a little bit strange, because, I mean, obviously, well, to check if a file exists, you actually don't have to read it. I mean, yeah, of course, you just have to check, well, does it exist on the disk? Yeah, I mean, obviously, well, you don't really have to open and read it. Right, then a program contains 6 modules. Right, so yeah, x. So I guess, well, this one takes 2 parameters. Right, then reset, so this is going to use by reference. Right, then, okay, so those 3 are all going to be procedures. Then we've got 3 functions. Right, we've got, okay, this one, restore, takes an integer, right, returns Boolean. Next one takes an integer and a Boolean, returns Boolean. And the next one takes an integer and returns an integer. Right, it says module X calls reset and module Y calls restore. Right, complete the structure chart for these modules. Okay, so, I mean, yeah, okay, I mean, let's try and sort of see what information we've got. Now, I mean, this one we think, well, of course, this is going to be some variable, right? And then, when we see black, well, that's going to be what a flag, right, a Boolean. But I think if we look at this one here, I mean, so this is going to be the one that's byref, because, well, again, let's say a double-headed arrow, right? That's going to be byref. So which one does it tell us, right? Byref, that's going to be reset. So yeah, let's just write reset here. And I suppose, yeah, I mean, let's just zoom out. Right, maybe not that much. Okay. Right, and let's also just give it the brackets because, well, they seem to give it the brackets here. Right, and well, let's label this then. So, right, this is called code. And then, right, so what calls reset? It calls right, x. So here, let's go what module x. Okay, right, module x. Right, so what does module x take? It takes what t1 and s2. So yeah, let's just draw both of these. Right, okay, this one can be T1, and let's do another one. Right, that's going to be S2. And I think, right, I'm just going to tick them once I've done them. So, I mean, reset, yeah, we've done. Right, module X, we've done. Right, then what else can we do? So, let's see what, I mean, module Y calls restore. And I mean, let's just check this. So, restore, right, that's going to return Boolean. So, yeah, I think we can say, well, this bottom one is therefore going to be restore. Of course, right, I mean, this one therefore must be what module Y. Yeah, okay, right, big Y. Right, so I mean, let's think then, right, restore takes, right, old code. Yeah, let's just write this parameter. Okay, right, yeah, old code. Right, and then, well, of course, well, the return value, I mean, we don't really have to give that a name. Right, and then Y, so, okay, right, Y takes what, RA and RB. So yeah, we actually need to draw another one. Right, let's go RA. And then, okay, right, so RB, that's actually going to be a Boolean. So let's make sure just to, yeah, highlight that. Right, and then this will also return a Boolean. So yeah, let's just draw a kind of flag like that, right? Make sure it's shaded. Right, okay, so we've done Y, yeah, we've done restore. I mean, yeah, module A, I guess, well, that's done already. Then I guess what the last one, so module Z. And then, right, so that takes an integer, right, let's call it SA. And, right, then it's just going to return an integer. Yeah, so, I mean, of course, if you tick them off like this, then hopefully you've not missed anything. Although I think these, maybe spend 30 seconds, just have a look at it again. Yeah, make sure you haven't missed any of the details. Right, then we want to explain the meaning of the diamond symbol as used in the diagram in part A. So of course, well, when it says the diamond, right, yeah, obviously it's talking about this one here. So the diamond, well, this just means selection, right? So basically just an if statement, or, well, I mean, yeah, maybe a case statement. So let's say, yeah, a selection. And we can say, right, well, maybe i.e., right, only one, yeah, only, okay, right, okay, okay, let's say only one, right, of, and then what that's going to be module x, yeah, module x, z, or y will be executed. Right, let's say, yeah, module, right, x, right, slash, let's say y, right, slash z, yeah, will be executed. I don't know what, depending on a condition. Yeah, or I don't know, maybe depending on the condition of the selection or something. Yeah, let's say depending on the condition of the selection statement. Alright, and then, yeah, I think the last one, so a class of students are developing a program to send data between computers. Many computers are connected together to form a wide network, and serial ports are used to connect one computer to another. Right, each computer is assigned a unique 3-digit ID, also has 3 ports, each identified by an integer value. They're connected to between 1 and 3 other computers. Right, data is sent as individual message strings, and each string contains the destination ID. Right, well, so yeah, the ID of the computer that's receiving the message, right, followed by the data. Messages may pass through several computers on the way to the destination. Right, when a message arrives at a computer that is not the destination, the program needs to forward it onto another computer using one of its serial ports. Okay, the port to use is obtained from information that's stored in an array root table. Right, root table is a global 2D array of integers. It's declared in pseudocode as follows. Right, so it's going to take 6 rows and 3 columns. Okay, the values in the first 2 columns of root table define a range of ID values, and column 3 gives the corresponding port number to use when forwarding the message to a computer with an ID within this range. Right, so for example, yeah, this root table, right, in this example, a message that arrives with a destination ID of 283 will be forwarded using port 2. Right, and then, well, the reason for that is because we see what 283 is within the range 260 to 239. Likewise, of course, if we add, 450, right, then it's going to be this one. And of course, well, this is therefore going to be the port number. Right, okay, row 3 in the example shows an unused row. These may occur anywhere. Right, unused rows have the column, column 1 element set to -1. Right, the value of unused elements in the other 2 columns is undefined. Right, the program has defined the first program module as follows: get port, and this takes a destination ID as a parameter of type string, and searches the range. Searches for the range corresponding to the destination ID in the array. Then it will return the port number or return -1 if no corresponding range is found. Right, we want to write pseudocode for get port and assume that destination ID contains a valid 3-digit string. Okay, now I've just opened this on the website. Of course, as always, go into exam questions, right, choosing this particular question. Therefore, we can actually have access to this starter code. Right, so what we can do then, right, I'm just going to paste the instructions. Right, so, well, this one then is going to be a function because it's going to return the port number. So, hang on, right, yeah, let's go function. Right, this is going to be get port. And yeah, let me just move this across. Right, it takes a destination ID, so let's go maybe, dest ID as a parameter of type string. And yeah, okay, right, that's all it's going to take. Right, then it's going to return, let's go returns. And this will be returns integer. Right, so if we think, this here is going to be a string, but if we actually look, if we go up here, of course, well, these are going to be integers, right? Therefore, we're going to need to convert this destination string, right, into an integer. So let's just go declare. Maybe let's go like dest ID, and I'll just say int. So yeah, just the integer. Right, and then yeah, is there any other local variables that we need? Yeah, I suppose. Since we're having a loop, let's just have an index, because basically this is just linear search, where of course, well, we're just looping through row by row, right, until we find where the destination is greater than or equal to column 1, right, and the destination is less than or equal to column 2. And of course we also want to check that column 1 shouldn't be -1. And then yeah, if it is, well then we just return column 3. Right, so let's just go ahead and do this. Let's go and okay, actually, well first, right, let's just let's just convert this to a to a number, right, to an integer. Right, that's going to be this dest ID int, and right, let's go. That's going to be what, string to num, and yeah, that's going to take the destination ID. Right, now we can just have a for loop. So let's go index. This will be 1, and let's go 2 6, because it says there's six rows in the routing table. Right, so then I think we just want to check, and this is going to be, what is it, root table. And of course, if we go up, you can see the root table, right, I've just defined up here already. Right, so let's go, right, this is going to be index because, well, this is the, right, so this is the index, this is the row. Right, then we want to say 1, so we want to check, well, this shouldn't be equal to -1. Then we want the other conditions where we say what the destination ID index, right, this should be greater than or equal to the root table. Again, well, let's go index, right, 1. And then, well, let's have another and in this case, what the destination ID, again, int, that should be what, less than or equal to, well, the root table. Again, it's going to be the same row, okay, the same index, but this time it's going to be column 2. And I mean, if it is, well, then I think we can just return. And what we want to return is, well, just column 3. So, right, let's go index and then, return column 3. Right, let's have end if, let's go next index. And here it tells us, well, if we don't find it, then we just return -1. Okay, so yeah, I think that should be fine. Right, let's go end function and let's try and test this a couple of times. Right, so get port, and what did it give us as the example? Wait, no, where is the example? Okay, right, so here then the example 283. And it said, well, that hang on, that should return. Okay, that should return port 2. Okay, so we see this works. Now, of course, if you want, you can try this for a few other values. But yeah, I think that should be fine. Right, and then so the next one, copies of the same program will run on each computer. The program contains a global variable myID of type string, which contains the unique ID of the computer in which the program is running. Right, when messages are received, they are placed on one of 2 stacks. Stack 1 is used for messages that have reached their destination, and stack 2 is used for messages that will be forwarded onto another computer. Right, additional modules are defined. Stack message, which is already written. That takes 2 parameters, a string representing a message and an integer representing the stack number. It will add the message to the required stack and returns true if the message is added to the required stack, otherwise returns false. Right, then process message, which I think this one is the one we have to write. Right, it says it's going to take a message as a parameter of type string, and it's going to ignore any message with a 0 length data field. Okay, it's going to extract the destination ID from the message, check whether the destination ID is this computer or whether the message is to be forwarded, and uses stack message to add the message to the appropriate stack. And then it will output an error if the message could not be added to the stack. Okay, so yeah, let's just try and copy all of this. And then I'm just going to paste it here under this one. Right, so process message. Right, this is going to be a procedure because it's not telling us to output. It's not telling us to return anything. Right, so procedure. Process message. Right, that's going to take a message as a parameter. Well, let's go message. And then right, that's the only thing. Right, it's going to ignore any message with a 0 length data field. So again, well, maybe let's think about what local variables we need. I suppose, we could have, let's say, the destination ID, because, well, of course, we want to extract that. Right, and then, I think like maybe that's all we need. Okay, then what we can do, well, we want to ignore any message with a 0 length data field. And if we actually go back, let's look at the format of the message. Right, it says here, so it's going to be what? Destination ID, then data. And it says, yes, I think what the destination ID is always going to be, okay, so the destination ID is always going to be 3 numbers. Which I think, I think it tells us that kind of somewhere here. I guess, it also kind of this part really. So what we can say is, well, if the length is 3, then of course, there must be no data. Okay, well, let's go here then, right? If length, and that's going to be length of messages, well, let's go greater than 3. And then let's have an else, and we'll go end if. So what do we want to do in the else? I guess, well, just ignores any message with a 0 length. Okay, I don't know. I mean, so like here, maybe we should just output a message. Yeah, or maybe we don't have to. I don't know. I mean, well, okay, let's say like message has no data. Because I'm not really sure if they want us to output a message or not. Right, the next one, we want to extract the destination ID from the message. Well, here then we just want the left 3 most characters. So right, let's go. That's going to be that's going to be left. Right, this takes message, and then of course, well, it has 3 because we want the 3 leftmost. The 3 leftmost characters. And of course, well, if you're not familiar with this, well, check the insert. The insert has all the examples. Right, then we want to check whether the destination ID is this computer or whether the message is to be forwarded. So I think, well, we can check if it's this computer because it tells us, is it called, like my ID? Okay, right, so the program contains a global variable my ID of type string, right, which contains the unique ID of the computer. Right, okay, so what we can check then, well, let's go if destination ID is not equal to, and well, that's going to be not equal to my ID. And of course, well, this is where we want to add it. This is where we want to add it to the stack. And again, like here, I mean, so like honestly, I think here, I mean, probably we don't have to have an output message. Alright, so I think, I mean, here, right, let's not have an output message. I think we don't really need it. Right, then what we want to do, so, right, well, we're going to use stack message to add the message to the appropriate stack. And if we see, well, stack message takes a string representing a message and an integer representing the stack number. Right, okay, so what does the stack number represent? Right, okay, so stack 1 is used for messages that have reached their destination, and stack 2 is used for messages that will be forwarded onto another computer. Okay, so I guess we actually do need an else statement here then. So right, I mean, so here then it said what stack 1, and I think is it a function? Okay, right, this is a function going to return true or false. Okay, I mean, so we could have another variable, let's say like, I know, message success, or added to stack success. Or let's say stack add success. Right, okay, that's going to be a Boolean. And then what we can do, well, let's go right here. So this will be stack add success, and then this will be stack message. Right, this takes the message, and then it takes an integer. So I think this will be 2, because this is if it's not. Okay, so right, this is if we're forwarding it to another computer. Stack 2 is right for messages forward on to another computer. Right, and then, well, I mean, let's just do the same. We'll just copy that, and then this will be 1 because, well, this is where if it has arrived at the destination. And what we then just want to do, I guess, well, then let's just output. So we can go if stack add success. Right, let's go if stack add success equals true. Then we can just write kind of sort of added to. Okay, so actually we don't need an error. We don't need a message if it was successful. Right, so let's go equals false. And we'll just go a message couldn't be added to stack. And I think in reality, well, the reason it can be added is basically if the stack is full. Right, and then here let's just go end procedure, and let's just check that we've got everything. Right, takes a message, yeah, we've done that. Right, ignores any messages with 0 length data field, yeah, we've done that here with this length. Right, extract the destination ID from the message, yeah, we did that. Right, checks whether the destination ID is from this computer, yeah, or whether it's to be forwarded, yeah, did that. Right, uses stack message, yeah, outputs an error. Alright, so I think we've done all of that. I mean, well, now let's just check it works. And I think what I'm going to do, yeah, let's make this stack size rather than 10, let's just make it 3, for example. And let's, okay, and we saw, hang on, so, right, my ID is 123. Alright, so what I'm going to do, let's go call, and we're just going to go, what is it, process message. Yeah, and hang on, let me just comment this, and then I'm going to do it down here where I can actually see this. I mean, I don't know, let's just say like hello. And yeah, okay, but alright, so here we also need the first 3 characters have to be the, the destination ID. So I'm just going to send, well, let's try like 4 messages to myself. And hopefully, yeah, I suppose if it's successful, it's actually not going to output anything. But then I guess what the, sort of the 4th time, I mean, I guess what on the 4th time then it will actually output. Right, message couldn't be added to stack. So, I mean, right, what I'm going to do just for testing, let's just go like success. But of course, yeah, in the real exam, I mean, I don't think you need this. Yeah, okay, so here we get, 3 successes. Now, let's try, for example, the other people. So this is, of course, what if we have to forward it on to someone else. Right, we'll try 999. In fact, I mean, well, let's have, right, 999, 123. Let's have another 999. And yeah, let's have another 999. So in this case, well, we should get 4 that are, so we should get 4 that are successful, and then the 5th one should be a failure. And yeah, okay, right, this seems to be working. Right, now is there anything else? Okay, yeah, so the program contains a module get file, which receives text files sent from another computer. Lines from the file are sent one at a time. Each message contains 1 line, and process message from part B adds each message as it is received onto stack 1. Okay, right, module get file removes messages from stack 1 and writes the data to a text file. There's a problem. Under certain circumstances, the received file does not appear as expected. Right, assume that while a file is being received, process message only receives only receives messages containing lines from the file. Right, describe these circumstances and explain the problem. Okay, right, so let's think about this. So it's going to remove messages from the stack. I mean, right, what happens then if the stack is empty? I suppose if the stack is empty, then what could possibly happen is, well, this get file could try to read some, or try to, pop something from the stack. And I mean, if it's not doing, proper sort of, checking, right, if the stack is empty, then I mean, like, maybe it'll just try to write an empty line to the file, so you're going to get all of these empty lines. I think maybe this is not the best kind of one, because I mean, well, I guess hopefully they would actually check for this, to check if it's empty, and then obviously only write something if they actually get a result back. So I mean, well, okay, let's think, right, what happens if the stack is full? So like we saw, let's imagine we have a stack size of 3, and well, let's say we let's say we sort of push on A, right, then B, then C, and of course, these can be characters, right, they can be strings. Right now, of course, well, what's going to happen is, well, first if we're popping that, right, first we're going to write C, then we're going to write B, right, then we're going to write A. So one thing you say, well, they're actually in reverse order. Of course, that's going to be written as CBA. But okay, I mean, well, let's imagine, right, before we pop them, and of course, right, this is the sort of top of the stack, right, this is the size of it. Like, of course, right, then if they try to add D, well, of course, I mean, that's not going to fit in the stack. So that's just like not going to be received. And then of course, when the person writes it, well, then they're obviously not going to have this line D. So I think we can probably say that. Well, circumstance, maybe, stack is full. Right, let's say stack is full when, right, new items are trying to be pushed to it. And I don't know, like, maybe you also have to say this because I mean, if you just say stack is full, well, the stack is full doesn't actually cause an error in itself. Like, of course, I mean, if we only have 3 elements that we want to write, or yeah, 3 lines that we have to write, then of course that's fine. But the problem is, well, if the stack is full, right, and then we try to add something else, well, of course, yeah, I mean, this new line that we try to add, this is not going to get added. Right, so stack is full when new items, yeah, maybe are trying to be, or maybe let's say, yeah, are trying to be pushed to it. Right then, explanation. I suppose what we could say, item won't be added to the stack. Right, yeah, item won't be added to the stack. Right, let's say hence. Right, so hence, when get file pops the items. Yeah, okay, when get file pops the items, one by one. Right, so what we can say, well, yeah, I don't know, like, well, this line won't exist. Yeah, okay, right, let's say, yeah, this line won't exist, hence won't be written to the file. Okay, right, exist. Yeah, right, I know, right, let's say, well, therefore. Okay, right, therefore won't be written to the file. Right, then suggest a more appropriate abstract data type that could be used to store the messages that would not have the same problem. Yeah, I mean, so I guess actually this is kind of telling us that, well, the problem of a stack, well, that's going to be last in, first out, right, or yeah, LIFO. Whereas, I mean, what we want is, well, FIFO, right, so first in, first out. Yeah, okay, that's an O. So, of course, we'll have FIFO data structure, that's going to be a queue. Where, of course, what we say is, well, yeah, obviously, I don't know, let's do it this way. Of course, well, the first element coming into the queue, right, I mean, that's going to be the one that's actually, written first, yeah, I guess, well, to the file. Right, anyway, guys, I mean, finally we've got to the end. Hopefully that video was useful, and of course, any questions you can just ask in the comments. And yeah, hopefully see you again in the next video.